Okay. Any questions you guys want to go over before we do the quiz?
No. I'm good.
Fix this stupid thing.
Okay. So the total area under the density curve must equal 1, right?
Yeah.
And under certain circumstances, the density curve can drop below the x-axis, and that's false, right?
Right.
Yeah. Mobile density curve is symmetric.
I put true.
That's true.
Yeah. Okay.
Use the following image to answer question 16. Which of the following elements of the figure represents the z-score in this image?
It'd be C, right?
I forget.
I thought it was like the...
I think so. Because A is the... Not A, the area is the, what do you call it? Standard deviation, right?
A is the probability.
Oh, I'm just kidding.
Okay.
So which figure? Or A is the probability that it's not bigger than 1, and then B is the probability that it is bigger than 1.
Okay.
Right. So 7 would be B.
Sorry,
What was 6?
Mm,
Sorry.
Yeah, 6 was C.
6 was C. Okay.
Well, RC is the bottom number 1, the 1.000. Okay, yeah.
Okay.
So
Yeah.
which of the following elements of the figure represents the probability that the random variable z will be greater than 1? That's B, right?
Right.
Yep.
According to the 6... Oh, I remember this. Proportion of data the bell shape will be within 1 standard deviation. So that's the 68 one, right?
Right.
Correct.
And then the second, within 2 deviations is the 95, within 3 is 99.7.
Yeah.
Yep.
Suppose... It says use the normal applet to answer this question.
Yeah, the
What's that mean?
applet that's in the book. So it says, what proportion of the values from this random variable will be between -1 and 1?
Accurate to 3 decimal places. Okay.
Okay. Suppose random variable z has a standard normal distribution. This is a normal.
Just like share your screen for whatever you're using.
Yeah.
So I was just curious to see how you're doing
So this is the applet that we're supposed to download.
it. Okay.
But I'm trying to figure out what the. So it says, what proportion of the values from this random variable will be between 1 and
Negative
-1
1.
and 1?
Yeah. So you just changed those to -1 and 1, right?
Yeah, I think so. In the bottom 2
So it'd be
numbers.
0.683. Is that right?
Yeah.
0.683.
Yeah, because it's 6827.
Yeah. .683 would be standard
So
deviation.
the next one, suppose random variable z has a standard normal distribution. Use the normal applet. So you can just keep that up. Use the normal applet to answer this question. What proportion of values from this random variable will be between -2 and 2? So do you just do the same exact thing, put a -2 and 2, or is this one different?
No, it's the same. And it's the same with the next one, the -3 and 3, I think.
Yeah. Here. For some reason, mine's not working anymore. You know, I'm gonna guess that it's 99 or 95-ish.
Oh, yeah.
Is that right?
I don't have it pulled up. You have to give me a second.
2 and -2. It's 95.5 or
So
0.955.
0.955. Yeah.
0.955, yeah. And then this one should be, so,
Makes you reload it every time.
yeah, let me see. There we go. I'm just using the one from the book now because it's working.
Oh, okay.
Okay, so that's 99 points, or 0.997.
997. Actually, this quiz wasn't as hard as I thought it was going to be.
Yeah, 12, it matches the,
The answers to the last 3 questions. What do you observe? So that's the
it would be the values match.
Yeah.
yeah. Oh yeah. Wow, I didn't realize that. Let's look at that. That's cool. Okay.
Okay. So then, see, the amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. Protein requirement is given in terms of the number of grams of food quality protein that must be consumed each day per kilogram body weight. I'm guessing that should say body weight. The population mean protein requirement for adults is 0.66 grams per kilogram per day, and the population standard deviation is 0.07 grams. Use this information to answer questions 14 to 17.
Which it means 13 to 16.
Yep.
We're probably going to have to use the applet for this.
Yeah.
So, what proportion of the population have a protein requirement that is less than 0.60 grams per kilogram?
So we need to get the z value.
Yeah, to
For
3
the-
decimal places.
So 0.6 and then minus 0.66 divided by 0.07.
Yeah.
So I got a z-score of negative 0.857.
So you just put that into there and then the positive value. Very cool.
And so the question was asking less than that number, right? So then we just want to highlight this. So then it's
0.196.
Yep.
Cool.
Okay, and
So the
then
next one is just more than. So just leave that same one up and click on the.
so it'd be the same.
Oh. 196. Okay. What proportion of the population have a protein requirement that is less than 0.70? So now we just need to do the 0.70 minus 0.66 divided by 0.07. Is that right?
Yeah, and then we should get a z-score of 0.5714. And so it wants it above that, right?
Less than.
Oh, less than.
Yeah, less than.
Okay. Then 0.716. Okay.
Wait, you had both parts highlighted. Are you supposed to have the both sections highlighted?
Yeah, because it wants the, so this right here, this represents that 0.7 grams.
Yeah,
And then-
well, what about the last one that we did when it was the left z-score we were using, and we only used the very right one. We didn't use the right and the middle.
Right, because
So number 14 should be different, shouldn't it?
no, it's because the question right here for 14 was, oh yeah, you're right. So more than, wait, no.
Yeah, so shouldn't 14 have been both of those? You see what I'm saying?
So 13 should be different, but not 14. 14 is that number, but
Yeah, let's recheck it.
13 would be, because what was it? So it's 0.6 minus 0.66 divided by 0.07.
Yeah, it was a negative number, so we start from the left one.
0, negative 0.87. Okay, so then the question for 13 was, which proportion of the population had
Yeah,
a
it's
birth-
less than.
less than? So then, yes, so then less than is right here, so that's
Yeah,
this.
but the next one should be the two
Okay, you're right.
ones to the right. You see what I'm saying?
Yeah,
So it's not 0.196. It should be whatever
0.804.
804. Okay. Glad I caught that.
Nice.
Okay. Okay, the last one. To find the area between two values, you can subtract the area to the left of each item. Make sure your answer is positive. This is the probability that a randomly selected observation will lie between the two values. Find the probability that a randomly selected person will have a protein requirement that is between 0.60 and 0.70. So you can just simply like
So we do
subtract the 15 and 13, or
you subtract the z-scores from each other.
okay,
So and we want a positive number, right?
yeah.
So we'll do this z-score for. Does somebody want to calculate this one real quick? The z-score for the 0.7.
Yeah, I can do it. Okay, so 0.70 minus 0.66. Yeah, 0.66 divided by 0.07. So that's 0.5714.
Okay. So then we should get a z-score of 1.28 or 29, sorry. And so the probability that it's between those two is this. So does everybody understand what I just did?
Yeah.
Yeah.
Okay, cool.
What does that say? 0.847?
Yeah.
Alright, we feel confident of these answers.
We blew through this super quick. This is like the fastest quiz we've ever done.
No, and I was thinking it was going to be
That
the
was good.
worst.
It's like we
Okay.
got one wrong.
Oh, we got the last one wrong.
Oh, dang.
Huh. So,
Could have been a rounding error.
this is find the probability that a randomly selected person will have a protein requirement that is between 0.60 and 0.0. Oh, it shows how to do it. So it says p of x less than 0.70 minus p of x less than 0.60. So it's So you're supposed. Oh, I was right.
Oh, you take the answers
Yeah.
in the previous
See, I
questions.
said it's just 15 and 13. You're just supposed to take 0.716 minus 0.196.
Yeah.
Just the difference of those.
Oh, okay.
Well, it's confusing me.
You're killing me, Spencer.
That's how they did it in the book.
Jeez, I had to save you on number 14 too.
I know, man.
I'm
That's
just
why we
giving
do
you a
this
hard
group
time.
quiz.
No.
So, okay. Cool, guys.
We're all good.
We will see you guys next week.
Alrighty.
Okay.
Same time, right?
Yeah, Monday at 8.
Okay, great.
Cool.
Should be good. Okay.